In this video, I'll be covering question 4, part D from the 2021 AP Calculus AB free response section, no calculator allowed portion. I cover A, B, C, and D all in their own individual videos, so if you want to find answers for A, B, and C, please go check out those other videos. The first thing that I do on any AP Calc question is that has a graph is I make sure I know what that is the graph of. So they're telling us straight up here that this is the graph of f of x. So I know the graph is f of x. Now let's go see what the actual question is asking for us. So what they want here on D is they want us to find the average rate of change of g on this given interval right here. That's the first thing they want us to do. Then this has a second portion of it that wants to know if the mean value theorem is going to guarantee us that the answer we get out from the first part is got a point that's going to be equal to the average rate of change, that the derivative value will equal that average rate of change that we get out from part 1 of this. Well, let's first go find our average rate of change, and then we'll talk about, after we do that, whether or not the mean value theorem applies here. So average rate of change, this is something you just got to know. Whenever they say the average rate of change, that's fancy math talk for slope as we've always known it, which is just y2 minus y1 over x2 minus x1. So in order to find this out, what we do is we say, okay, they've given me my x values. So I know that x1 is going to be -4 and x2 is going to be +2. Well, in order to find out the answer to this problem, I need a y1 value and I need a y2 value. Well, how do I get y values? I take the x value that I care about and I plug it into my equation. Well, we're talking about the g equation here. So to find out what y1 is, that's going to be g of -4. To find out what y2 is, that's going to be g of 2. And to find those values out, we did this type of process. If you watched any of the other videos for A, B, or C, you know how we did this. We've got an equation here for g of x. We know that g of x is equal to the integral from 0 to x of f of t dt. Well, if I want to find out what g of -4 is, remember this is just function notation. Function notation always works the same. Whatever I replace x with here, you replace x within the equation. Even if it's an integral, the function notation doesn't care that it's a funky looking thing. It just cares that you do what you're supposed to do. So we do integral from 0 to -4 of f of t dt would get us that answer. And then to find y2, I would just be doing g of 2. And so this would be the integral from 0 to 2 of f of t dt. Well, to find out what these integrals equal, that's the next part of the game. The integral is always equal to the area between the curve and the x-axis on whatever interval it is you're looking at. So as we go through, that's what we're going to be doing here. When they don't give us an equation to work from, these are always going to boil down to really just geometry shapes and finding the areas of some standard geometric shapes. So let's look at g of -4 first. The first thing we got to do on this integral before we can start working with it is remember that our lower bound and our upper bound, we always need the lower bound to be the smaller number, the upper bound to be the larger number. So the first thing I need to do on this is I need to flip my bounds. So to flip the bounds, I do what I call it pulling the negative. I don't think that's proper math talk, but it helps me remember what to do. I put a negative up in front of my integral, and that allows me to now flip my bounds. So this will be the integral from -4 to 0 of f of t dt. Now what I'm going to do is I'm going to come over and I'm going to look at the graph from -4 to 0. So -4 is there and then 0 is there. And so what I'm trying to do now is I'm going to be trying to find the area of all of that shape through here. What you're going to be doing is you're going to be using your standard geometric formulas for areas. So you just got to know these. You're going to need to know the area of a triangle formula, which would be 1/2 base times height. You're going to want to know the area of a rectangle formula. That'll probably get you most of what you need, so this would be base times height. But if you want to kind of increase your speed and get going quicker on some of these, you're also going to want to know the area of a trapezoid formula. You need to know that in general because sometimes on the AP Calc test, they're going to ask you to do a Riemann sum using trapezoids, so you better know the area of a trapezoid. So the area of a trapezoid formula is 1/2 base 1 plus base 2 times the height. So if you remember a trapezoid looks like this, it's going to be base 1 times base 2, and then your height is whatever that gap is right there. So let's go look at the first area. So from -4 to 0, the first thing that I notice about this one is I kind of want to stop it right here at -2, and I'm going to go find that area of a triangle right there. So that piece is 1/2 base times height. So the base on this would be 2. And then the height is going to go all the way up here to 6. And then I'm going to add to that. And if we look at this, this is a trapezoid here. It's a trapezoid that's been turned on its side. So the bases are going up and down, and then the height is right here. So it'll just save you some time if you can use that trapezoid formula. So base 1 is going to be the height on that side. So that's going to be 6. Plus base 2 is going to be that side right there, so that would be 4. And then this time the height is going to be this gap right here. That height is going to be 2. So if we put all that together, we do our math on this, we get that 2 is going to cancel out with that 2, leaving us with a 6. We're going to get 2 and that 2 are going to cancel us out and leaving us with a 10. And so we're going to get 6 plus 10 is going to get us 16. But do not forget that you pulled this negative earlier. And so really what we get out of here is -16. So g of -4 is equal to -16. Now when we come to do g of 2 is now going to be this triangle right here. And then this triangle right there. That's going to be the area between 0 and 2. Again, if you've seen my other videos, then you know that those two triangles are the same size and they're just going to cancel each other out. But if you haven't, then we'll kind of go through it just to make sure you're not left in the dark. So this first portion here, that's a triangle. That'll be 1/2. The base on the bottom is 1. The height is going to be up to 4 right there. And then we'll add to that the next triangle we're going to do is going to be 1/2. The base on that is going to be 1. And then the height on that triangle there is going to be a -4. And so what we see is that those two things canceled each other out. And so in the end, that equals 0. So g of 2 equals 0. Now that we've got our x1 and our y1, our x2 and our y2, we've got everything we need to pop into our average rate of change formula. So we just do that. We go y2, which is 0, minus y1, which is -16, over x2, which is 2, minus x1, which is a -4. And so then out of here, you're going to end up with 0 plus 16, the negative gives us a positive, so 16 over 2 plus 4, the negative again gives us a positive. And then we could reduce that down, 16 over 6, we can pull a 2 out of the top and a 2 out of the bottom. And so we know right now that our average rate of change between -4 and 2 for our equation g is 8/3. All right, so first part of this is taken care of. Now we got to come through and we got to say, okay, does the mean value theorem apply? Well, in order to figure that out, we got to remember what are the requirements of the mean value theorem. The mean value theorem requires first that the graph is continuous on the closed interval from A to B. So in our situation, A and B, this would be, is it continuous on the closed interval from -4 to 2? And then the second thing is it differentiable on the open interval from A to B? So on the open interval from -4 to 2. Okay, so what we need to do right now is this is talking to us about g of x, and this piece is talking to us about g prime of x. So how does that relate back to our graph? We need to be able to kind of understand what we're looking at in terms of the graph up there. And so again, this is something that we saw earlier in the earlier videos. We know that g of x is equal to the integral from 0 to x of f of t dt. That we know is continuous. We can look over at our graph over here of f of t, and there are no breaks in that graph. That graph is complete all the way through. There's no jumps, there's no holes. So we know that yes, it's continuous. And now what we got to do is say, well, how does that relate to the derivative? So we take the derivative of both sides. We ddx both sides of this. This is the Fundamental Theorem of Calculus, part 1. Whenever you've got a number up to a variable here, an equation in your bounds, really this is always going to boil down to the Fundamental Theorem of Calculus. And what the Fundamental Theorem of Calculus says is when I take the derivative of this side, I get g prime of x. And when I take the derivative of the other side, a derivative and an antiderivative cancel each other out, and whatever's in there is going to drop straight down. So f of x. So what we can now understand is that g prime of x is equal to f of x. So what we also know is that this is the graph of our derivative. And again, there's no holes in this graph. The trap is they want you to think about those sharp corners, but you don't care about the sharp corners because you're looking at the graph of what the derivative was. If there wasn't a derivative value, you would have a hole on this graph. You'd have a break in the graph. There's no holes, there's no breaks, and so what that means is the derivative existed all the way from -4 to 2. So this is differentiable on that interval. So we have found that both of those things are true, that the graph g of x is continuous because we know that the integral is possible all the way. So g of x is just the integral, remember. And so g of x works all the way through here from 0 to 2 because we can get a value out for that integral everywhere. And then the derivative is the actual graph, and we know that the graph didn't have any breaks. So yes, we are guaranteed that there is some value c that lives inside -4 to 2 such that g prime of that value would equal 8/3. And when they do this, they want you to tell them this. You have to kind of say these things are true, that g of x is continuous on this interval, and that g prime of x, that it's differentiable on that open interval. So tell them that, and then draw the final conclusion of the mean value theorem, which says the derivative somewhere in that interval will equal the average rate of change. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.